Welcome, MSTC friends. This is section 4.4, f of x terminology and systems as models. So this f of x thing, it is, the first thing you need to know about it is it's another way to say y. The reason we need f of x terminology is because if we're in a word problem where we've got more than one thing going on. You know, we've been dealing with more than one linear equation. So let's just say we're talking about the new car you want to buy. Let's say that your new car costs you $5,000, and then it costs you, let's say, I don't know, $75 a month to drive. Okay, so this is one option for a car. Let's say it's a clunker old truck. It's cheaper at $5,000, but it costs you $75 a month to drive. So this is a mx plus b form. It's just I put the 5,000 first, so no big deal. So this, we call this the truck equation. And then let's say that your other option is a hybrid, and the hybrid costs you $10,000 up front, but because it gets amazing gas mileage, it only costs you $40 a month to drive. Okay, and one main reason that we have f of x terminology is if I start into a problem about this truck and this hybrid, I've got y and x, the same letter, standing for different things. This initial y up here stands for the total cost to own the truck, and the other y stands for the total cost to drive the hybrid. And it's never a good thing to have the same variable standing for two different things. So f of x terminology, this is an example. I could call this first equation t of x equals 5,000 plus 75x. And I could call the next equation h of x equals 10,000 plus 40x. Okay, so now I have two different functions, t of x and h of x. And while I'm thinking of it, don't confuse these parentheses around the x with multiplication. This is not t times x, this is t of x. And it's just, it gives y a new name, basically. And the most common letter you'll have for your function is f of x, just for function. But, okay, so there's the reason that we need f of x terminology. Let's just do a couple problems. You'll probably get problems, or you will, that look something like this. I'll just give you a function, f of x equals 2x squared plus 4x minus 11. And then the question will be something like, what is f of 2? So f of 2 just means plug 2 in for x. It's simpler than saying what does y equal when x equals 2. F of 2 is a faster way to say it. So one thing that trips people up is whatever goes here goes in every x. No matter what is in these parentheses, it gets subbed in for x. So f of 2 is 2 times 2 squared plus 4 times 2 minus 11. And that's 2 times 2 squared is 2 times 4, which is 8, plus 4 times 2 is 8, minus 11. And 16 minus 11 is 5. Okay, so f of 2 is not very complicated. The ones that tend to cause problems are what we would call this a function call. Let's do something like f of x plus 1. Not every time you're going to have just a simple number here that you plug in for x. But like I said a second ago, whatever is in these parentheses is going to get subbed in for x every single time. Okay, so I'm just going to sub x plus 1 in for those parentheses, or in for that x, excuse me, and see what I get. So if I plug in x plus 1 where I had an x, that's what it looks like. And then I had 4 times x, so I'm going to have 4 times x plus 1 minus 11. All right, that's the thing right there that people struggle with. Whatever is inside this function call right here goes in for x in your original function. And put it in parentheses so you don't mess up your order of operations. Okay? So first thing I do is square these parentheses. And when you square something, the most common mistake I have in every class I teach that's at least Algebra 2 or above is people want to distribute this squared over those parentheses. The big no-no. You cannot distribute squared over parentheses. You write it twice and FOIL it out. You don't have to write it twice. If you can FOIL it in your head, then good for you, but if not, write it out twice. FOIL it. And this 4 is going to get distributed in the minus 11. So I'm going to distribute my 2, and I get 2x squared. I already had 2 x's in there. If I put these two terms together, then the 2 from the outside gives me 4x plus 2 plus 4x plus 4 minus 11. And then group all your like terms. Get 2x squared, the only squared term. I've got 8x's total. And then I have a 2 and 4 and a negative 11. So that's 6 minus 11, negative 5. So long story short, f of x plus 1 equals all of that. Okay, it doesn't have to be just a single numeric answer. It can be another expression involving x. Okay, so here on the next page, we've got a situation where you have two separate functions defined. F of x is x squared, and g of x is 2x plus 4. Remember that f of x and g of x both just mean y. So if you were to graph this, your y-axis would be where you graph the values of f of x and g of x. Nothing is changing about what you know about these things. It's just the name. Okay, so one example might be, what is f of g of x? Okay, and I cannot stress enough, whatever is in these parentheses, in this case, g of x, gets placed right there where x is. Okay, I usually make up a stupid example for my classes. If, over here on the side, what would f of, let me find a stupid example. What would f of smiley face be? Okay, whatever is in those parentheses goes in for x in your function. So f of smiley face would be smiley face squared. All right, and I know that's stupid, but it helps bring home the point. What would g of, let me find another, what we got here? What would g of star be? G of star would be 2 star plus 4. Okay, so if my question is what is f of g of x, then whatever g of x is gets placed into x squared. So f of g of x equals 2x plus 4 all squared. Okay, this makes sense. Whatever is here is going here no matter what. So then again, I'm not going to square 2x and square 4 and be done. I'm going to write it twice and FOIL it. 2x times 2x is 4x squared. 2x times 4 is 8x. 4 times 2x is 8x and 16. And then group your two middle terms. Okay, so if you remember, whatever is in that function call gets substituted in for x in parentheses, you will be in pretty good shape. Just remember the stupid examples on the right, the smiley face and the star, and that'll help you out. Okay, so word problems in this section will go something like this. I'll just give you a few quick examples. These are our functions for the cost to drive the truck and the cost to drive the hybrid. And since we're talking about systems of equations, the solution to a system of equations is where these two cross. So the question might be, for example, you know, it's going to cost you more up front to own the hybrid because it costs $5,000 up front. The truck is cheaper, but it costs more to drive for months. So an example question would be, how many months until the cost to drive the truck has outweighed the cost to drive the hybrid. Or when will basically T of X equal H of X? When will the two costs be the same? So if I want to find the intersection to this, basically I'm just going to set my two functions equal to each other. I'm going to say when will cost of the truck equal cost of the hybrid, and then just 5,000 plus 75x. When will that equal 10,000 plus 40x? It looks a little different, but basically we're doing a substitution method of solving here. Okay, so I'm going to subtract 5,000 from both sides and get 5,000 over here. And I'm going to subtract 40x from both sides and get 35x over here. Divide by 35. Divide by 35. And 5,000 divided by 35 is 5,000 divided by 35 is 142.85. And in our setup, this was in months. Okay, so it's going to take you 142 months, which is 12 years-ish. 144 months would be 12 years. So this is 11 plus years for your truck to cost more than your hybrid. There's obviously a lot of other factors, like whether your truck is broken down at this point. But strictly speaking, if this is the cost of the truck and the hybrid, you're better off with the truck for the next 11 years. So that's just one quick example. Other examples, they'll say, how much does it cost you to drive the truck for 18 months? And you'll plug in 18 and solve. But really, the ultimate question is always going to be, what's the intersection of these two? And I'll just make a quick graph. It won't be anything fancy. But if the hybrid costs 10,000 and the truck costs 5,000, and then the hybrid is going up at $40 a month, and the truck's going up at $75 a month, those two would cross here at 142.85 months. If you want to know what that cost would be, you could sub in 142.85 back in and see what those costs would be. So we'll talk more about these word problems in class and do more examples, but main points for today, function notation is just another word for y. It's usually f of x. If you have a problem asking you for f of 2, plug in 2 for x. If you have a problem asking you for f of x plus 1, plug in x plus 1 for x. Whatever's in those parentheses gets subbed in for x. Okay, f of g of x, take the entire g function and plug it in for x. Remember the stupid examples with the smiley face and the star, that'll help. And then we'll get to more word problems like this. Okay, so I hope you enjoyed this section 4.4. I'll see you in class. Young out.